everybody, this is Ms. Fitzgerald again, and in this video I'm going to go over a supplementary video for 9.2.3 study. So this is mostly about series circuits. This video is optional, but it's just to clarify what the apex was going over about series circuits. Okay, so the first thing we need to know is we need to know how to draw a circuit and represent it. Okay. So this here is the symbolic representation of a circuit, and this zigzag line here represents a resistor, and a resistor could be anything. It could be a light bulb, it could be a refrigerator, it could be a toaster. It's just something that's resisting the current. And at the top we have our battery. The longer line represents the positive end of the battery, and the shorter line represents the negative line. So from here, we can figure out what direction the current is flowing and what direction the electrons are flowing. And we should remember that current flows from positive to negative, and electrons move from negative to positive. This is because when they first came up with current, they said it was moving charges and they had not yet discovered the electron. So they assumed the charges were positive, and it turned out that they were actually negative. So unfortunately, now we have current is always the opposite of electrons. Okay, so this is how we draw it. Now, if we want to do a little math here, let's say we have in this resistor, let's say our resistance is going to be 75 ohms. Okay, and our voltage is going to be 9 volts. And if we want to figure out what is our current, so if we want to do this, we need to use our equation V equals IR. And we're trying to get I by itself, so we can divide by our R. And we have I equals V over R. And so from here, if we just have one resistor, it's pretty simple. We just plug our numbers right in, and we get 9 over 75. Which gives us 0.12, and the unit for a current, if you remember, is amps. Go back to my previous video if you're a little confused about units. So this would be our answer. Okay, pretty simple. However, we could also have a circuit that has multiple resistors in it. So if we could have a circuit that looks something like this. Okay, and this would have 3 resistors in it. Okay, this would have R1, R2, and R3. We say when we have these 3 resistors all next to each other, we say they are in series. Okay, and what we should have seen in the apex work is that the current through each of the resistors is the same. There's the same amount of charge that flows through each of these resistors. However, the voltage drop can be different. Okay, so I'm just going to write that down so we remember. So current is the same. And voltage drop is different. However, if we have a total voltage here, we know, let's say that our total voltage is 120 volts. We know on the positive side, we're going to have 120 volts, and by the time we get all the way around, it will be 0. So altogether, the voltage drop across all 3 of them is still going to be 120. And so for that reason, we can replace these 3 resistors and redraw this circuit with an equivalent resistance. I'm going to do that right now. Okay, so now we still have the same voltage, and now I'm going to call this REQ, the equivalent resistance. Now we can calculate REQ by just adding up all of our resistors. And this is, of course, the case for series when they're all next to each other. Okay. So now if we want to do the same problem, if we say, let's say V1 is 120 volts. Okay, and let's say R1 is 50 ohms, R2 is 75 ohms, and R3 is 100 ohms. I should keep my units. Okay, and if we're trying to find I, okay, how do we do this? So we're going to want to use that same equation, V equals IR, or as we found before, I equals V over R. But in this case, we're going to say V over R EQ, okay? So the first thing we're going to have to do is calculate that R EQ. So we just add these things up. So I have R1 is 50, plus R2 is 75, plus R3 is 100. And if I add that all up, I should get an equivalent resistance of 225 ohms. So now I just plug right in. I go 120 volts over 225 ohms, and I will get my current to be 0.53 amps. Remember that amps is the unit for current. And this would be our answer. Okay, so what I did in this case was I combined my 3 resistors into one, and I called it my equivalent resistance. I calculated that equivalent resistance by just adding up the 3 resistors. And then I went back into my V equals IR equation, and I just plugged in my equivalent resistance and the voltage I was given to find the current. Okay, and we know the current is the same through each of them. So the current through R1 is 0.53, current through R2 is 0.53, current through R3 is 0.53. However, the voltage is different, so we can actually take this one step further and then calculate the voltage drop through a particular resistor. So let's say we want to figure out voltage drop through R2. Okay, and again, these are going to keep going back to the same equation here. So I would be using my equation, V equals IR. And in this case, now we do know the current that's going through R2, because remember, they're all the same. So my current is that 0.53 amps. And R2, I can look back and see that that's 75 ohms. And then I would just calculate that. 0.53 times 75 is 39.75 volts. And this will be the voltage drop through R2. So in total here, first I use my equivalent resistance to find the current, and then I use that current with a particular resistor to find the voltage drop across that resistor. So these are basically all the types of calculations you're going to be doing with series circuits. The only other thing that was mentioned in this apex that I want you to understand is the difference between a short circuit and an open circuit. So if we have something like this. This is a circuit with no resistor in it. If it has no resistor, this is a short circuit. And these are really dangerous because you get too much current. And when you have too much current, you can have things catch on fire, they can heat up too much, so this can be very dangerous. So this will be a short circuit. You could also have something called an open circuit, which looks like a normal circuit, except it has some sort of break in it. This is an open circuit, and the problem with an open circuit is that current cannot flow through it. That's why if you had 3 light bulbs all together and one of them blew out in series, then all of them are going to be dark because you now have an open circuit. So we have an open circuit, current can't flow because there is that gap in the circuit. So these things sort of work together in something called a fuse. And a fuse is an open circuit that happens to prevent a short circuit. So if you have something in your home Maybe you've blown a fuse before, like if two people are using a blow dryer or something like that. When that happens, that means that you were demanding too much current and it got to a dangerously high level of current that could have resulted in a fire or something dangerous like that. And that caused your fuse to trip. And when your fuse trips, you now get an open circuit. And then that shuts off everything, and so it's not dangerous. So what a fuse does is it opens a circuit if current is too high to prevent a short circuit. Okay. So these are the main ideas from this 9.2.3 study, both parts. Understanding how to represent a circuit, how to draw it, then understanding how to make calculations with series resistors, and then understanding the difference between a open and a short circuit. So if you have further questions about any of those, please let me know. Otherwise, have a wonderful day.